Schrödinger's cat just got a little bit fatter. And here's why that's a big deal for physics. In the case of this experiment, Schrödinger's cat is not an actual cat. It's 7,000 sodium atoms all clumped together. But to understand what all of this really means, we have to start with superposition. This is where something can exist in multiple possible states at once. I know that sounds wild, but this is how quantum mechanics works, at least at the level of individual particles. The trouble is, we still don't know at what point things stop behaving according to quantum mechanics and when they start to behave like you and me, who can't be in multiple possible states at once. Right? This is what Schrödinger was getting at with his cat. Let's say we've got a radioactive atom in a box that's isolated from the rest of the world. We've also got a vial of deadly poison and a cat. Whether or not the poison gets released depends on if this atom decays, and that's a quantum process. Now, if we close the box, and we can't see what's happening, then the atom is in a state of both decayed and not decayed. But does this superposition apply to the other things in the box? Is the poison both released and not released? What about the cat? Quantum physics says that until we open the box, it's neither alive nor dead. It's in a quantum superposition of both. I know, poor cat. But it gets at the key question. At what size does a quantum superposition stop being possible? This is where the 7,000 atoms come in. Physicists are trying to find out if there is a boundary, and this chunky cluster of atoms is the biggest Schrödinger's cat they've made so far. Since atoms can't be alive or dead, physicists are trying to figure out if they can put these clusters of atoms into a superposition of locations. So they shot a beam of these clusters at a screen with gaps in it and saw something like this lovely interference pattern on the other side. That tells us that the clusters must have been behaving like waves, travelling through a number of gaps at once, spreading out and overlapping. In other words, 7,000 atoms are not too chunky to be in a quantum superposition. I cannot emphasise enough to you guys how hard this is to do. Quantum states are really delicate, and everything about the outside world is trying to mess it up. The whole setup has to be kept at minus 196 degrees centigrade and an ultra high vacuum, so that not even a stray air molecule can disrupt what's going on. So even though the researchers' next steps are to do this with something bigger, that's not as easy as it sounds. If all goes well, in the next decade or two, it might be possible to put the first living thing in a superposition. Schrödinger's bacterium, anyone? And somewhere along the way, we're hoping to find the missing piece in the Schrödinger's cat puzzle. At what point do things stop being quantum?